Turn there. We are learning today about how to identify proportional relationships. Please pull out your red pen, and I want you to fill in this section of your notes. Okay, so today's lesson is going to be all about proportions. You can see here the definition says it's two ratios that are set equal to each other. Now, if you remember, we have talked about ratios before. We could say it like this, 1 to 2. We could say 1 to 2. Or in this case that we have right here, we have a fraction 1 to 2, okay? So right now what we're talking about is two ratios that equal each other, or in this case, two fractions that equal each other. This is just telling us that 1/2 equals or is the same thing as 3/6. So today we're going to talk about cross products. Cross products are going to be a way that help us to understand if something is proportional or if something equals each other. So if you would, take your red pen. We're going to circle this diagonally, 3 and 10. Basically what you'll end up doing is multiplying those things that are diagonal, 3 times 10. Now I want you to take your red pen and circle this, the 4 and the x. What that means is I'm going to set it equal to 4 times x. So today in our lesson, we are primarily talking about cross products and how this can help us to see if things are proportional or not. If they do equal each other, that means they form a proportion. Let's look at the first one. Tell whether or not the ratios form a proportion. This says 6 to 4 and 8 to 12. So we're going to write this as 6 over 4. And remember I said this is two ratios that are set equal to each other. So I'm going to say equals 8 over 12. For today, we're going to be using cross products. I want you to take your red pen one more time, and we're going to circle what comes diagonal from the other one. What is diagonal from 6? 12. Everyone circle it diagonally. What is diagonal from 4? 8. We've talked about this before. We want to have nice, neat work. So with your pencil, I'd like you to drop down your equal sign directly below the other equal sign. On the left-hand side, I'm going to start with what I am multiplying here, the 6 and the 12. So on the left side, show me the step 6 times 12. Now on the right side, we are going to put in 4 times 8. Drop down the equal sign once again. We're going to focus on the 6 times 12. Girls, what is 6 times 12?
72.
72. Boys, what is 4 times 8? 32. Class, does 72 equal 32? No, I want you to take your red pen and put a little slash through it. This says 72 does not equal 32. If those two do not equal each other, then they are not proportional. So the instructions say, tell whether or not they form a proportion. The answer is no, they are not proportional because they did not equal each other. Okay, let's go on to problem B. It says 10 to 40 and 2.5 to 10. The first one, we're going to turn that into a fraction. 10 over 40 equals, because remember, a proportion is two fractions that equal each other. What will I write for the next one, Ellie? 2.5 over 10. MJ, what is diagonal from the 10?
10.
Okay, so everybody circle the 10 and the 10. Jacoby, what is diagonal from the 40? 2.5. All right, drop down your equal sign to make sure your work stays lined up. Jace, on the left side, I'm going to put 10 times 10. What do you think I should put on the right side? Very good. And it doesn't matter which order you put it in. I could have said 40 times 2.5, or I could say 2.5 times 40. You're going to get the same thing no matter what. Let's drop down the equal sign. Halen, on the left, what is 10 times 10? 100. On the right, Reagan, what is 2.5 times 40?
10.
Not 10. 2.5 times 40.
Oh.
I think you put in 2.5 times 4.
4. Yeah.
100. Jonathan, does 100 equal 100? Because they equal each other, the answer is yes, these do form a proportion. On a scale of 1 to 10, 10 being I totally get it, 1 being I'm totally lost, show me where you feel on problems A and B. All right, so I've got like between 7 and 10. That means you're pretty much understanding it. So I'm going to throw in some fractions. Let's see if we can still do it with fractions. First things first, it says 1/2 to 1/4. Remember, we're just going to put the first one and divide it by the second one. So 1/2 divided by 1/4 is equal to, Luke, what should I put on the right side?
8/4.
8/4. Remember, with cross products, we are going to circle them that are diagonal from each other. Jocelyn, what should I circle?
You should circle 1/2 and 4.
1/2 and 4, and what else?
1/4.
Very good. Everyone drop down your equal sign. Jocelyn, what should I write on the left side? Let's just start with the top left one. What are you going to write? 1/2 times 4. And we'll put that over a 1. Jocelyn, what will go on the other side?
1/4.
Excellent. Autumn, can I cross reduce anything?
No.
On this left side, is there anything that goes into a 2 and a 4?
Oh, yes, 2.
2. So what do they become?
2 and 1.
Very good. What about the right side, Autumn?
2 and 1 again.
2 and 1 again. Maddie, when you multiply this out on the left side, what do you get?
2, 1.
Okay, 2 over 1, which just means 2 divided by 1, which is 2, so I'll leave it as a 2. And Halen, what do you get on the right side? 2 also. Boys, does 2 equal 2?
Yes.
So the answer is yes, these do form a proportion. Okay, I want you guys to try to do problem D and E on your own and see how you do. Okay, as I walked around, I saw a lot of people with excellent answers. Who feels comfortable and would like to do problem D for me? Jocelyn, what should I write?
6 over 9 is equal to 12 over 18.
Very good.
Then you do 6 multiplied by 18. And then equals 6 multiplied by 12.
Very good. And what is 6 times 18?
108.
108. What is 9 times 12?
108.
Does 108 equal 108?
Yes.
So yes, these do form a proportion. Great job. Who'd like to do problem E for me? Luke.
So you put 2 over 3 equals 4 over 5. You you make like a diagonal circle from the 2 and the 5 and the 4 and the 3. And then you drop down your equal sign and you put 2 times 5 on the left and 3 times 4 on the right. And then you drop down your equal sign again and then you multiply them so you get 10 equals 12. And they don't equal each other, so it's not proportion.
Very good. Those are not equal to each other. All right, let's flip to the next page. Number 2, it says, tell whether or not the quantities are proportional by finding the value of the ratio. So if you look at this right here, this box looks different than the other ratio tables that we've had. Can someone explain to me what is different about this ratio table versus all the other ones we've done before? Ellie, what's different? Okay, there's an X and Y, which we've had that before, but what else is different about it? Michaela?
Fractions?
Fractions, we've had some with fractions. What else? Halen?
They have all the blanks on the molecule except for me.
Look at this. I already know all of my X's, and I already know all of my Y's. The difference is now I am just trying to figure out what the value of the ratio is, and if the ratio is the same all the way across. So this is a little different than what we've done before. But let's just remind ourselves, if I am working from the top to the bottom of a ratio table, what should I do? I have to divide. Okay? Then the opposite, obviously, if I'm working from the bottom to the top, I would multiply. So in this case, let's write this out. We have the first one, second one, third one, and fourth one. This will help us just keep our information a little bit organized. Let's start with the first one. I know the top and I know the bottom. So in this case, I'm just going to work from the top to the bottom. If I work from the top to the bottom, should I multiply or divide? I'm going to divide, okay? The key word today is divide, all right? So I'm going to take 1/2 divided by 3, which means 1/2 divided by 3 over 1. Maddie, what should I do next? Not cross reduce. Am I allowed to divide fractions? So what method should I use? KFC. Keep the first one, flip the second one, and change the operation. Maddie, when you do that, what's your answer? 1/6. Let's box that in because that is the first value of the ratio. Now, in times past, we then would take this and put it all the way across here. But our goal right now is to see, is the answer 1/6 all the way across here? So we're going to go on to the second one and try to figure out if the next one would also be 1/6. The next one, I know the top number and the bottom number, so we're just going to divide the two. What should I write? We're going to start with the first number, which is a 1. Divide it by the second number, which is a 6. Do I need to reduce anything?
No.
So guess what? That's the answer. So far, does it seem as if these are proportional, yes or no?
Yeah.
Yes, the first two both have the same value. Let's go on to the third one. Who can help me with how to find the value of the ratio for the third one? Jonathan.
You got 3 over 2 and put a 1 and then put 3 over 2 divided by 9
Excellent.
and then you can see and put change keep the first for the second change
Very good. Can I cross reduce anything? Yes. What goes into a 3 that also goes into a 9? Another 3. So the 3 becomes a, and the 9 becomes a. Excellent. When you multiply that out, Jonathan, what do you get? 1/6. All right, so far so good, guys. It looks like everything is proportional. We just have to see if this last one also equals 1/6. So let's put a little 4 down here. To Kobe, in order to find the value of the ratio, should I add, subtract, multiply, or divide?
You should divide.
Divide. Very good. I'm going to take the top number, which is?
2.
And divide it by the bottom number, which is?
12.
12. Jacoby, is there anything that goes into a 2 that also goes into a 12?
Yes, ma'am.
What is it?
2.
A 2. So I'm going to reduce this by dividing on top and bottom by a 2. Jacoby, when you reduce that, what do you get?
You get 1/6.
1/6. Class, did I have the same value of the ratio across the whole table? So somewhere here you want to simply write yes, that's your final answer. Yes, it is proportional because the value of the ratio was the same throughout the entire table. Okay, so one more example, problem B. As you can see, there's 4 different things we're trying to figure out if they are proportional, yes or not. So put a 1, 2, 3, and 4. Reagan Stevens, what do I do first to figure out what this value of the ratio would be? Should I add, subtract, multiply, or divide, Reagan? Divide, very good. Take the top number and divide it by the bottom number, and what do you get? Reagan. 2/4. Can that be reduced? What would it be? 1/2. Okay, so the value of that first ratio is going to be 1/2. Going on to the next one, Nasir, what should I do?
Divide 4 by 2.
Excellent. Divide the 4 by the 2, and what do you get? 2/1, which is just a 2. So far, class, does it look like this is going to be proportional?
No.
It does not look like it. Let's go to the next one. Jace, what should I write for number 3 to find out what that value of the ratio is? 6/1. What is 6 divided by 1?
6.
6. Very good. Also, once again, I am seeing this is definitely not proportional, but you do want to fill in the missing values for everything. Final one, Jonathan, what should I do?
Drop in the 8 and wait.
8 divided by 1/2. Okay, and if you want, you can put 8 over 1. What do I do?
Flip the second one.
Okay, and what's the answer?
16 over 1.
16 over 1. Simplify that.
16.
16. So the question comes back, class. Are these proportional? No, because the value of the ratio was different across the entire table, they are not proportional. Okay, modeling real life. You swim 20 laps in 16 minutes. Of the total laps swam, you completed your first 4 laps in 2.4 minutes. Are the rates proportional? Raise your hand if you know how to swim. Okay? How many of you have ever raced on a swimming team? Back in high school, I was on the swim team in 9th and 10th grade, okay? So I can understand this right here. Do you think you swim at the same speed at the beginning, the middle, and the end? No, as you continue swimming, when you get closer to those 20 laps, you're getting tired, okay? So let's see if this would be proportional. The distance and the time you swam throughout the entire thing from the beginning to the end, okay? So first things first, it says you swim 20 laps in 16 minutes. Let's write this down. 20 laps per 16 minutes. If you remember, a proportion is 2 fractions set equal to each other. So this is going to equal something else that I'm comparing. Who thinks you know what I should write for the other fraction? Autumn.
Divided by 16.
I need something else on the right side, though. Another completely different fraction. Jonathan, what do you think I put?
4 laps over 2.4 minutes.
Okay, 4 laps over 2.4 minutes. Okay, so this is giving me a proportion, 2 fractions that equal each other. Here's one thing I want you to notice. On the left side, I have laps at the top. So on the right side, I have to have the same thing, laps on the top. On the left side, you will see minutes at the bottom. So on the right side, you have to have minutes on the bottom. We're doing cross products once again like we've been doing all throughout the day. So we're going to circle diagonally the things that I need to multiply. Everyone drop down your equal sign. Jace, what do you think I should write on the left side?
20 times 2.4. Oh, 16.
No. Either one is fine. Okay, it doesn't matter which one you put first. So we can do 20 times 2.4. And on the right side? 4 times 16. Okay, so once again, the question that come up, does it matter which order? No, because this equals each other no matter what order, yes or no, okay? So help me out, Jace. What is 20 times 2.4? 48. And Autumn, what is 4 times 16?
64.
64. Class, does 48 equal 64? No. So the answer is no. These are not going to be proportional. Any questions about how to figure out if a rate is proportional or not? Okay, I want you guys to read problem B and do it on your own. Okay, I saw a lot of good answers as I walked around. You do 120 sit-ups in 3 minutes, and your friend does 148 sit-ups in 3.5 minutes. Do these rates form a proportion? So let's talk about our proportion. Haylin, what should you write for the first part?
Okay. So for the first part, we would put 120 sit-ups over 3 minutes.
Okay.
Equal. And then put 148 sit-ups over 3.5 minutes.
Excellent. Okay, once again, you can see sit-ups are on top on the left side, on top on the right side. You want to keep those things, sit-ups per minute, the same. Okay, Haylin, keep going.
Okay, then you're gonna do a little arrow, or you can just like this.
Okay.
And then you're gonna do the and then you put 120 times 3.5 equals 3 times 140.
Good job. What is 120 times 3.5?
It's 420.
Okay. And on the right side, what is 3 times 148?
144.
Okay, do those equal each other? No, so the answer is no, they do not form a proportion. All right, so tonight's homework is going to be a flipped classroom, which means you are going in to watch the 5.4 video and actually take the notes at home.